Right, so what are confidence intervals? Confidence intervals are a way we would create a range when finding a proportion of a population or a proportion of a sample, and we're trying to find the true value of people who do something or don't do something by creating a range. So first you have confidence intervals, which in this survey we used 90, 95, and 99. Then we use that to find a critical number by using a z alpha over 2, and then we multiply that by the margin of error, by the standard error to get the margin of error. Then we take p hat plus or minus the margin of error to create this range. So that's what a confidence interval is. Now the way we conducted our survey is we did it in 2 sessions. Once we stood at the entrance of the school, and once we stood at the exit to the school to the lunch patio, both for 1 day. We gathered all of our data by asking every third person the series of 10 questions, or the series of questions that applied to the person specifically. Then we took all that data, found averages, found p hat successes, q hat no responses, and utilized that to find confidence intervals and the ranges of which the answer may lie. And then after every confidence interval, we answer it with we are blank the confidence interval percent confident that the true proportion of students who do whatever the question asks is, and then the range. And that's true for your critical numbers. We use t when we're dealing with mean, and we use z when we're dealing with a proportion. Hi, do you mind if I ask you a quick question for a survey?
I don't mind at all. Anything you want.
Have you heard of this survey before?
Nope.
Alright, so do you wear your natural hair color?
Yes, I do wear my natural hair color.
Thank you.
No problem.
Okay, so when we asked kids if they wore their natural hair color, we asked 114 people, which is N, our sample population. P hat, the amount of people who said yes over the total population, is 0.904. The amount of people that said no over the total population is 0.096. So now, in order to do the confidence intervals, we need to first meet 3 conditions: random, normal, and independent. Was it random? So since we asked every third person of a random group, because it was just people who happened to be walking at the area at the time, we did random systematic sampling, first check for randomness. Now, normal. If we take p hat, the amount of people who said yes, and multiply it by the total population, we get 103, which is greater than 10. Also, when we take the amount of people who said no times 114, we get 10.9, which is also greater than 10. Therefore, it is normal, because both p hat and q hat times the total population is greater than 10. Independence. If we take 10% of the total population, the total amount of people who go to crop is around 2,700. And 10% of the total population is greater than our sample size of 114. So independence is met. Now, when we take the 90% confidence, we take p hat 0.904 plus or minus z alpha over 2 for 90%. So we get 1.65 times the square root of 0.904 times 0.096 over 114. After you do all the math, you get the interval from 0.8585 to 0.9495 contains 90%, with 90% confidence, it's between those 2 intervals, and this would be your margin of error. So we are 90% sure that the proportion of students who wear their natural hair color is between these 2 points. Now you repeat the same steps for 95% and 99%, and what changes is the z-score, alpha over 2, because when you're taking the confidence interval, the percentage relates to the z-score. So now when you do this one, we can say we are 95% sure that the proportion of students who wear their natural hair color is between 0.8499 and 0.9581. Now repeat the same calculations, but get the z-score alpha over 2 for a 99% confidence interval, which is 2.58. You get 0.094 plus or minus 0.0712. And you get an interval between 0.8328 and 0.975185. What we notice overall as a trend is that as the confidence interval increases, the interval also increases.
This was an interesting topic because wearing your natural hair color is not something that you can see visibly. You actually need to talk to the person, so it was revealing in that sense. And also, it was interesting to see the amount of people that changed their appearances in our school, since the percentage that we got was really high. So the results were shown by Josh in the previous clip, and there might have been some bias in that people might have been embarrassed to share with us that they dyed their hair color, or like if there were friends around, they might have been embarrassed to reveal the truth about their hair color. Hi, do you mind taking a quick survey?
Of course not.
So, do you own at least one dog?
Yes, I do own at least one dog.
Okay, thank you.
No problem.
So for this topic, we tested the proportion of students that own at least one dog. So our sample size was 114. Our p-hat, which is the percentage of students who own a dog, is 0.509. Our q-hat, which is the percentage of students who answered no to this question, is 0.491. Then we had to test our conditions. For random, we do have a random sample because it's a systematic sampling. For normal, we had to do p-hat times the sample size, which is 114, and q-hat times the sample size of 114. And those two numbers have to be greater than or equal to 10, and they were. So we have a normal sample. Then for independence, we had to find 10% of the total population. If that was greater than our sample, and it is, because 10% of the total population of our school is greater than 114. So then for the confidence interval, for 90% confidence, our critical number is 1.65. So we multiplied that times our standard error and then took our p-hat, which is 0.509. We did plus or minus our margin of error, and we got our interval from 0.4317 to 0.5863. Then we did the same thing for 95% confidence, used the same numbers. The only thing we changed was the critical number to 1.96, and then our interval was 0.417 to 0.601. And then we repeated the same process with a 99% confidence interval. So our critical number was 2.58, and our interval was 0.3882 to 0.6298. So as you can tell, as our degree of confidence increases, our interval is gonna increase in size as well, because we're more confident that the actual number will be in that interval.
The proportion of students who own at least one dog was a very interesting topic, in that we got to know more about students than just by looking at them. Also, it was a very easy survey to conduct because like students wouldn't be embarrassed to say if they have a dog. So yeah, that was very convenient. And for the results, my companion Aaron explained it in the prior clip, so we're good with that. And then the bias that could have been included in this survey is that people might have lied and said that they had a dog, because like people love dogs and like they would desire to have one, so they just lied about saying it. So we would call that social desirability bias. So yeah, that's about it.